Before we're able to do any incremental die analysis, the first thing we have to do is design our die. So I've already done that in my CAD system, and I have those files ready and waiting for me to import into my analysis. So in Dynaform, that's the first thing I'm going to do. I'm going to go ahead and bring this blank in. You look at it from the top, you can see I've got a little bit of shape to it. And then I'm going to go ahead and mesh it. And that's a very important step in any FEA analysis. That actually is breaking the part up into these small pieces, and then for each piece the simple-ish equations are applied to them over and over to get our results. So the next thing we need to do for that blank is to go ahead and assign a material. And so you can see that Dynaform has a substantial library of materials. I'm just going to grab a commercial quality steel in this case. You can see there's my stress strain curve that it pulled from the library, and of course it's very easy to import or to input new materials into that library so that you have them. Next we need to do the same thing for the die. So I'm going to go ahead and import in my die surfaces, so we can see I've got a little bit of a channel here with a little bit of S shape to it, and then mesh that as well. So what Dynaform does is gives us smaller elements in the radii and bigger ones out in the flats. So this is a good representation of our model. This is a good mesh. And then for this particular case, what I'm going to do to save a little bit of time is I've only drawn one side of the tool, and I'm going to, inside of Dynaform, I'm going to offset the punch and the binder. And so this lets me do my analysis earlier in the design process. I don't have to do as much work in the CAD system. And that, of course, lets me know what's going to happen in the die and make sure that I have a good design before I say I'm done with it. The next step here, if we look at this from the end, will be to go ahead and open the tool up. And you can see that we've got the upstairs cavity, and in red here the binder, and then the material is going to be trapped between those two. And then they'll be stretched over the stake. So that process that I just described has two steps. One where it closes, and then the second portion where it's stretching. So that's these two steps here. While that thing is being stretched over the stake, I'm going to put about 40 tons of force on that binder. This particular window allows me to set up any configuration inside a Dynaform as far as cams and any sort of gas cylinders upstairs, downstairs, that sort of thing, and be able to analyze any job. So from here, it's time to go ahead and run the solver. So we have everything set up. This particular job runs for about a minute and a half. So once that would happen, we'd have these results. And what I usually do when I look at my results is I start out by just looking at the blank. And I like to start out by looking at the forming limit diagram. Now the forming limit diagram is quite useful because kind of all in one spot it's going to tell me if my part has formed correctly, if it's going to wrinkle, if it's going to tear, by color coding it. So we can see on this particular one, if I go to the end, I have no red, so I haven't torn the part at all, and I have pretty little of the blue and pink telling me that I have wrinkles, so this part looks pretty good. So I could go on and look at some other results. I could look at the thinning of the material, how much we've thinned that down, what the thickness is. In this case we're looking at a percentage, maybe 17% thinning in these areas of red. You're also able to look at a simulated circle grid analysis, along with just plain old stress and strain and that sort of thing. So these plots can give you some good information. If the design isn't good, you can use these plots to make decisions about your next move. Are we going to reduce the binder force? Are we going to increase it? Are we going to change the design? All these sorts of decisions can be made with the results that you get out of Dynaform.